Hi, welcome to Cloud Cover. Here's Steve.
And that's Ryan.
Hey, we got a great show this week. We'll be covering the news as always, whatever tickles our fancy. Additionally, we'll be covering the table storage API, kind of showing you how to get started with it, some tips and tricks, and really answering those questions on how do you partition your data, how do you use the storage client in very practical scenarios. For some of you, this could be old hat. Hopefully you learned some new tricks. And for some of you, this is an introduction to something you've probably never seen before. We will round out the show with a tip on how to troubleshoot a very common situation when you query the table service and figure out how to work around this scenario in terms of providing the proper query syntax.
Yep.
Now, for the news, we will start with Mr. Eugenio Pace again from the Patterns and Practice team, or Eugenio Pace. Eugenio Pace.
Exactly. He's got a good blog post here. It's part of the Windows Azure guidance that is actually now content complete, but not really done and wrapped up. But this is one of the latest of his blog posts about that. And it's about what should really be second nature to everybody building cloud services, which is design for failure. Just assume that at any moment, at any line in your code, even in between, in the middle of a line of your code, the server may just burst into flames in the data center. It's rare that it actually bursts into flames, but hard drives fail, memory goes bad, whatever. I mean, there are a lot of reasons why it's a good idea to plan for just being able to pull the plug at any moment. And so, on his blog, Eugenio has an example of taking some code that looked sort of reasonable and did a try catch and sort of recovered from some errors, but really didn't work in the just unplug it kind of scenario. So he's refactored that code so that you could stop the execution at any moment. And the worst thing that would happen is you'd have a few entities that have to get cleaned up. You'd have sort of a garbage collection problem. But the correctness of the application is still intact.
Aha. So it's very idempotent.
Idempotent.
Wow. That's great.
SQL Azure team blogged about select into with SQL Azure, and really what they blogged is you can't use select into with SQL Azure. Select into gives you a table that doesn't have a clustered index, and on SQL Azure, all tables must have clustered indices, and that means you can't use select into. So instead, you just need to create the table and then do an insert into. So it's not a big deal, easy workaround, but something to watch out for that just might catch you off guard if you didn't know about it.
And I think temp tables can have non-clustered indexes.
Temp tables are allowed to have non-clustered indexes.
So it's just the ones that
But you still can't use select into.
Correct.
Select into sort of across the board in SQL Azure won't work, but it is true that temp tables don't need to have a clustered index. Next up is a blog post from the App Fabric team, and basically they're talking about this app infrastructure event. So it's a virtual event. You can attend it. It is on May 20th. It's going to cover a number of Microsoft technologies, including BizTalk, Windows Server, and the Windows Azure platform App Fabric. So check that out.
Firestarter.
Yes, so another event. This one took place some weeks back now, and I actually gave one of the presentations there. And all of the videos are now online. So it was a live event plus webcast, and now you have sort of the on-demand views of all these things. Some good, interesting talks, sort of standard what you'd expect, some overviews about the platform, about SQL Azure, about storage, but some more advanced talks about building applications and migrating existing applications to the cloud. And so even if you feel like you know what to expect from a one-day training about Windows Azure, I think you'll still find something in these set of videos that will interest you.
Which one did you do?
I did the platform overview.
Aha, so here's the one that everyone needs to focus on.
That's the one, really. The rest are just kind of filler.
Filler. Okay, that's good to hear. All right, the Windows Azure storage team, they have been cranking out the blog posts lately. This one in particular is pretty interesting. They talk about backing up your blob data. In this case, what they're doing is they have a bunch of code in here that uses the snapshot capability within Windows Azure Storage. So it's actually a very cheap way to back up your code because, as you know, the snapshot capability does not store additional data. It doesn't copy the bytes. It simply stores the delta of the bytes. So therefore, it's a very easy way to back up your blobs against what would be application errors. So as you know, we keep 3 copies of your data. This really isn't optimized around us losing a data center or anything like that, but it's more the case where you wrote some bad code, had some malicious users, this kind of thing, and someone deleted a container or something like that, and you lost all your blob files. On the same type of topic, they doubled up with how to protect your tables. Now, the code in here actually goes through and shows how to back up all of your tables. And again, this is for application level errors. If someone accidentally corrupted the data or you had code that was miswritten, accidentally dropped the table, this kind of thing, you will at least have a backup of your table data. Very interesting to read this. You can pull this code down, try it out yourself.
And the technique itself is kind of interesting because tables don't have something like snapshot. So to back up the tables, they're actually exporting everything to blobs,
right,
storing a bunch of blobs, and there's some code that knows how to sort of restore from those blobs rather. So just kind of interesting, even if you're not after the backup thing and you just want to see, hey, how do you get sort of that table data in some other structure? That's in here too.
And finally, we noticed this out on the Codeplex. This is actually someone who's written a table storage backup and restore service. So if you don't feel like taking that code that was posted in the blog, you can actually deploy these roles that this guy has actually created. And you deploy it in either a worker or a web role, and this will automatically take care of the backup for you. Now, obviously using your storage account and your compute account to host this particular code, so this is not a hosted service, it's something that you run yourself. However, it will give you kind of a pre-boxed way to just go out and say, back up this table. It does some nice things in here as well, for instance, encryption and compression and things like that. So very interesting, take a look. I haven't played with this yet, but it looks like something that would be useful.
Looks very cool, yeah.
All right, well, now that we're talking about tables so much, probably makes sense to step over to the whiteboard for a little bit and actually kind of give you an overview of how table storage works and how to think about it before we jump into some of the code we have here. At a high level, if you remember perhaps from last week, we have this thing called a storage account. The storage account is something that you create out on the portal. Now this storage account relates directly to that URI that you're going to program against. So it'd be like accountname.table.core.windows.net. In the storage account, you can have many different tables. So you can have, table 1, table 2, table 3, and you can have as many tables as you want up to the limit of the storage account. So in this case, this is a 100 terabyte limit. That's really your only constraint. This is across your blobs, tables, and queues data. But you could put as much or as little as you want in here. Once you've created a table, you can actually fill these with entities. Now, we call these entities flexible entities or schemaless entities. And the way to think about these is that it's really just a name-value pair of simple types like strings and integers and GUIDs and booleans and date times and things like that. There's a few mandatory properties per entity. So let's assume that I create an entity in here. I'll call it, entity 1. I'm going to have a few mandatory properties. I'm going to have something called a partition key. I'm going to have something called a row key. I'll just kind of abbreviate that for now, and then I'm going to have another required one called a time span. Now the time span is system maintained. We use that for concurrency purposes. After these 3 mandatory properties, we have anything you want in here up to a certain limit for the size of the entity itself. That happens to be 255 total properties and or 1 megabyte for the total payload of the entity. So you can fill within these constraints pretty easily most of the time. Now these can be anything that you want. So you could have like, first equals Ryan, last equals done, date of birth equals, 12, 1, I think I was born in 65 or 85. I don't remember. Anyhow, these things will actually be interpreted as you store them based on the type. So if I put this in string format, it's going to interpret as a string. If I put it into date time, it'll be interpreted as a date time. So when you round trip these. Now, the other thing to consider here is The format itself is really up to your interpretation. So what this means is a lot of times you will use a CLR type to interpret this. And this could be something like a user class that you create in C# or VB.NET. And it will have properties that conform to these table properties themselves. So you might have a user class that has a first, a last, and a date of birth as public properties. Additionally, you're going to want to include these properties as well, primary key, row key, and a timestamp, as just mandatory properties on your entity. If you look within our API, you'll see that we have something called a table service entity, and it actually is a base class that really includes these 3 properties, and you can just inherit from that and then add your own in there as well. Okay, now the last part of this is we want to talk a little bit about the partition key. So this is pretty important. This partition key is something that might be a little strange if you're used to the SQL Server world, in which you don't really think about partitioning your data, or at least not up front. We expose this directly in the model, and what it tells us is how we can partition our data across our service, and in some cases gain scalable data. Now I'm going to erase this picture. I almost said delete, as if I could undo it later. But I'm going to erase this picture here and kind of draw another one up there and talk about this partition. Now, the partition is a set of related entities. So when you choose a partition key, you generally want to choose a partition that's big enough that there's some commonality within a query that you might work on this set of entities. If it was a user, you might choose, the last name or the first letter of the last name to partition them by. If it was like orders, maybe it was the date or the month that it was done. But you kind of want to choose a partition that groups these orders or groups these entities together in some meaningful format. From a purely logical model, if I were to draw entities here, as indicated by these little boxes, and my whole set of data is this big long tube thing here, what you're going to have is at some level you're going to have partitions of data, like this could be A, B, C, and D. They don't have to be equal partitions, but you're going to partition it somehow. From our storage service perspective, we have this service head where you're going to route all your requests in. So you're going to make a request to account.table.core.windows.net, and that's going to get routed to behind the scenes one of the many servers that could possibly be serving this data. All these servers have visibility of the data, but in general, when they first get routed or when you first create it, you're going to get assigned one of these servers as kind of the keeper of your partition. So in this case, if we first start out, you might actually have all partitions located at this server. If you make a request, you're going to get routed here, and this is going to return to you your queries, or you're going to do your updates and deletes through this. What happens is over time, we look at the partition traffic and we decide if there's, at some point, we need to scale this out. So we'll take what are called hot partitions and we might move them around. Or we might move them to a server that has more resource. So if we saw that A and D, for instance, were getting pretty hot and there were a lot of requests, we might actually move these over to A and D over here. And this server would no longer take requests for A and D. And instead, if you did the routing, you would see that you're now routed behind to 3 separate servers serving the same data. This should tell you right away, aha, if I partition my data correctly, I can actually get a linear scale out depending on my traffic usage. So if I was consistently hitting A, D, and B, I might actually separate those queries into 3 parallel queries, which would give me at the same time, I could have all 3 of these serving that, and I'll have this linear scale out. Whereas if they were all located on the exact same server, I would be resource constrained by the capacity at that particular storage node. Now that you kind of understand how the partitioning impacts how your data is stored and served, you can kind of get into a mental model into your mind that says, hey, I should partition my data into the chunks that are going to make sense based on my query usage, because the query usage is going to determine how we determine how to scale out your data. The other point I'd put in here, and I might be putting words into Steve's mouth, is if you find yourself writing a query against our table service without a partition key in your query, you should probably think to yourself that that query is incorrect. There might be a few edge cases where that's not the case. However, I'd say the vast majority of the time, you're going to want to always use a partition key in your query for this exact reason. Okay, let's step into the code. Now, the first thing I have here is what you might recognize from Steve's talk last week or his show last week, which is how to get set up with just your storage account credentials and creating the client. There's an extension method where we have create blob client, queue, or table client. In this case, I've chosen to create the cloud table client. Once I have this, you can see that there's a few methods that are exposed in here. For instance, creating tables, deleting tables, listing tables. Those are really the ones that you're primarily going to work with. In this case, what I want to do is get an idea of the tables that are in my service right now. So I will call list tables, and I will dump those to the output. Now, when I do this,
List tables is a method there.
Yeah. When I do this correctly, you will see that I'll get an enumeration of all the tables. If you are using the diagnostic counters or the diagnostic capabilities in your code today in Windows Azure, these tables should probably look pretty familiar. In this case, I have my infrastructure logs table. Now, let's suppose that I wanted to actually query this logs table and I wanted to get data from it. Now, there's a couple ways I can do this. One, I could find some CLR types that match to exactly what that logs table is. I can create a table service context, I inherit from it, do a few things and set it up. Or I could kind of use this iterative development that I'm going to show here to show you how to get this done a slightly different way. So first things first, the syntax for any query is going to be first create a context, and in this case we're going to say client.getDataServiceContext. Now this context is actually a table service context, which is the type of class that we have. If we were to look at the methods in here, you would see things like how to add objects, how to execute the batch, how to detach or attach to something, save changes, all those things that you would expect if you're used to using the WCF data services client. Used to be called Astoria, and then ADO.NET Data Services. Now it's WCF Data Services.
And just as soon as we all get the hang of that,
yeah,
I'm confident we'll change it
we'll
again.
change it again. Exactly. So you'll see in here that we have, we've just kind of overridden the data service context and created a table service context, which has a few more things like storage credentials and other things on it. But in general, it's basically a data service context. Now, once we have that, we create a query by, strangely enough, saying create query. Now, this expects a type, however. Now, the type is what is going to be serialized to come back to you. So in this case, I'm going to say, I'm going to create a foo. I don't have a foo right now, but that's okay. I'll create a foo later. I want to create a foo, and I want to use the diagnostic infrastructure log table as my data source. So in this case, I'm creating this, I'm going to query this table, and I'm going to return everything in the form of this foo object. All right, let's do that. I've created this query now. I need to actually create a foo in order to hold this. So here's a foo. And you remember I said everything has at least 3 mandatory properties, a partition key, a row key, and a timestamp. Let's go ahead and put those in. Pop, string, partition key.
Starting to appreciate why you use LinkPad for these things. It's kind of handy, actually.
Okay, now we know we have these particular on every entity. We also have a whole bunch of other stuff, and I don't know what that is yet, but we'll find out. When I first actually call this query, there's a lot of data in here, so let's do a take one. I'm going to ask for the first item here and dump it out, q.dump. Okay. Now if I didn't make any mistakes here, I'm going to actually see some data come back. In this case, here's the first entity, and you'll see that the partition key, row key, and timestamp are returned. Now there's more information in here. What I really want to do is find out what that is. There's a little trick you can do, which is either go to like something like myazurestore.com and use like a general querying thing that does this discovery for you, or you can actually, from the context, go ahead and just grab that reading event. And what we're going to do is we're going to add to this a Lambda function here that will, in fact, output for us what that is. And the data, as this reading event is fired, is actually an XML element that represents the Atom pub document, or that particular element, as the serialization happens. So in this case, I'm going to take the data and dump it. Now when we run this again, you'll see that I have all this XML coming back. And this XML shows me a few things, which can be interesting. It shows me a bunch of properties in here. So if I look at it this way, you'll see that I see things in here like the role instance, event tick count. You see all these properties in here, event tick count. You see my drawing's very good. Event tick count, function line, MD result, error code. These are all the data that's actually stored as a property or within my entity. Now, some of the stuff in here that looks interesting, I see message in here. That looks pretty interesting. I see error code. That might be interesting. Why don't we add those to our particular? So I'm going to copy and create a new property in here. What I'll do is I'll just add this message in, and now when I request something, this is going to be serialized back and retrieved on that object. So you'll see I have that in there, but here's the message. Okay. Now I'm going to get rid of some of this stuff. I don't really care about the other things in here right now, so I'm just going to get rid of this reading entity stuff again. And then what I want to do is take a look at how we query things a little bit more. So first things first, let's dump out what our particular query is actually transformed into. We can take the query and cast it as a data service query of type foo. And then there is a request URI that we will output. This request URI represents what actually is, if we were to look at it in Fiddler, this is actually what we would see on the wire in terms of the gets and the puts and the posts and the things like that. This is the actual URI that we'd see. So when you do something like this, create query take one, this is actually being an expression statement that's compiled down into this iQueryable, which is then transformed into a particular URI in this case. So if I run this again, you'll see that I forgot to put take one. Oh, that should work. I don't know what happened there. Okay, you'll see that I actually have this top one within here now. Okay.
And this is OData, right? That's what this is.
Yeah, this is just OData.
And the only thing that's different here is that because it's a table service context instead of a regular data service context, the authentication is a little bit different in table storage.
Right.
But the URLs are the same. The XML that comes back is the same. So if people are trying to figure out kind of what that syntax is, I mean, that's the place to look. It's really not a Windows Azure specific thing. It's actually the OData format.
Exactly. And you'll see that as we change the query, so if I put in a where clause in here, so, you know, f dot error code or timestamp, you know, greater than date time now. You know, I put any query in here that's legal. What you'll see is that the query itself is composed down into something that looks like this. In this case, you know, filter date time greater than date time, and it actually formats that all for you. Now you see that I didn't get anything back in this case. Nothing in here, and the timestamps is actually greater than date time now. Surprising.
So that there are no future events.
I'm shocked that there were no future events. Okay. Now this is querying. It would probably be worth it. It's not a big stretch, but it'd probably be worth it to talk a little bit about update, delete, and create. really simple to do. Using the context, if we had a foo, so if I have var f is, some new foo, and I actually put some data in this foo, for instance, I could do a context add object, and I would just simply pass in, the name of the entity set. In this case, it'd be that WADS diagnostic. I'm not going to copy it here, but it's the name of that table, and then the foo object itself. And when I call context save changes, that will actually commit the object up into Windows Azure Table Storage. Additionally, if you had, for instance, let's say we had a query in here, okay, in this, like for instance, this particular query, where we take the first one, and let's say I wanted to update this one. Well, what I would do is I would get the first instance of it, so q.first, which will give me, the actual serialized foo in this case. And I'm going to say varf is this foo. What I want to do is change the foo now, so f dot, message equals updated. And if I commit this back to the context, it's doing context update object, it will actually, and then a save changes. You always have to do save changes. It will actually go and update this. Under the covers, this is also using what we call optimistic concurrency. So if the object that I've pulled back, this first foo from the query, has that timestamp on it, when I submit it back up, if the timestamp is actually changed, meaning someone got in there in between it, this will actually fail with an exception. Now, there are ways to override that and say, just ignore it, push it in always, or things like that. But in general, this is going to be the pattern you use. The delete is pretty similar in here. Instead of update object, you would say delete object.
Should we talk a little bit here about transactions and what you can do? Because there's one of the options for when you call save changes is to specify save changes.batch, I believe is the save changes options.batch.
Yeah. So one of the save changes options in here is batch. What happens is if you had a whole bunch, let's say you had a whole bunch of deletes in here and some updates, and these were different objects, foo, 2, 3, and 4. These were different instances of foo. You could actually kind of batch all those up and submit it with a save changes options batch. And as long as your payload didn't explode past, I think, 4 megabytes when you created this batch, and as long as you didn't do operations on the exact same object, you can actually submit this as one big payload, and the service will take it and process it all at once.
There are a couple restrictions on kind of what you can do transactions are, right? And one is that if you remember the diagram that Ryan showed us about different servers handling different partitions of the data, well, one of the requirements is that everything has to be in the same table in the same partition.
Exactly.
So if you're going to do a batch operation, they all have to be in the same table within the same partition, because that means they're all going to the same server and they can actually happen as a transaction. Anything that's cross-partition or cross-table is potentially on different servers, and we can't guarantee any sort of transactions around it.
Exactly.
So that's a requirement, and the other requirement is there's a maximum number here. You can actually only have 100 operations within this same batch. So I've seen a pattern of looping over a bunch of things, keep a counter, when it hits 100, push them all in one batch, and then move to the next thing. It's a decent idea.
If you have pretty lightweight objects, it's easy to do that. If you have an object that's actually pretty bulky, if you're using larger table entities, you do have to be wary. There's also a 4 megabyte, I believe, payload size. So it's either 100 or 4 megabytes, whatever comes first.
Right.
But this is an easy way to kind of get that transactional capability. A lot of people, like if you look at the post by Eugenio, they were using that batch capability to actually save expense items. So the expense report would have many items. They would save that whole list of expense items in a single transaction. So now at this point, we've looked at the update, the delete, and the create. We talked about the querying. It's probably good to take a look at some of the things that might be confusing if you didn't know about them. So in one case here, let's say that we had this query and we wanted to do an order by on it. So order by F goes to F dot, let's do the timestamp again. So we're going to take this query, and remember, this is an expression. It gets compiled down and put on the URI. When it gets dumped out, let's go ahead and q.dump that particular query. You'll see that we actually get an error. And the reason is pretty self-explanatory in the inner exception. It's not implemented. So not every single operation within your link provider is going to be supported at the WCF service head. Instead, you're going to have to look at the set of operations that are supported. Right now, those are things like simple predicates, the take operation, things like that. So greater than, less than, equal to, those kind of things. What isn't supported are kind of the more advanced options that you might do, like joins or sorting or
group
by and aggregates, sum and count and things like that.
Yep. The most common ones that people get surprised by, I think, are order by and count. Those are the ones that people sort of think that they'll be able to do. They can't do them in the cloud. There are actually reasons for that, right? I mean, order by can't really be done efficiently without an index, and we don't index any of the properties other than the partition key and the row key. So you can't really do an efficient order by in the cloud. And count is actually fairly problematic. I mean, count, when we're talking about billions of entities, as we tend to in Windows Azure tables, that's a non-trivial operation, and a better way to keep a count if you need it is to actually just explicitly keep that count up to date. So as you add something, increment the count. That way you don't have the expense of kind of enumerating everything to count them.
The good news is you're not completely out of luck, though. Let's say you really did want to do this query. It's important to realize that you can always pull down the results and then use link to objects locally and do this. The easiest way of doing this is to just say as enumerable here. And to keep in mind, so what's going to happen here is the first part of the query right up to that where statement is going to occur. So you're going to get all of those results enumerated back to you. Then you're going to have locally the order by and the take happen. That might not be what you think you wanted, so you have to kind of keep in your mind what's occurring on the server and what's occurring on the client in memory.
Right, and for example, I mean, this one will end up pulling down every single entity in the entire table.
Exactly.
Right, well, that matches the where clause, right? But it'll do everything that matches the where clause. Then it's going to sort the whole thing, and then it's going to take the first element.
Exactly. And the sort and the first element take will be in memory on the client.
Right.
So as you can see,
So don't be surprised when you see this. You open up Fiddler and you see megabytes and megabytes of data being transferred when all you're trying to do is get one entity. It's really important to be just be aware of where these things are happening. But for a lot of cases where you need to do sorting or something, it's actually, you needed to get all the items anyway. You just need to display them in a certain sort order. And then sorting them locally is a perfectly reasonable thing to do.
So if I take a look, one other thing that's probably comes up a lot is how do I get more than, if I run this query and I look at it in Fiddler, what's going to happen, what you'll see here is actually run this.
You need a semicolon, actually.
Yeah, looks like I missed that. Let's just put it here. Run this and then if I look in Fiddler, you'll see my queries come across. You'll see the tables, you'll see the diagnostics. If I take a look at the actual response that came back, there's a couple things to notice. The big one is we have these things in here called continuation tokens, which is the next partition key and next row key. There's a value in here. It's a little opaque, but it's a marker that the table service can read and figure out where they left off. If we took a look at what's returned, it's going to return to us either the maximum number of results, which in this case is 1,000, or it's going to return to us whatever range it could before crossing a partition boundary. And if you crossed a partition boundary that happened to be served by another server, for instance, you could get a continuation token in that case as well. So if I look back and see this, you'll see that I only got 1,000 items here in my iQueryable foo. If I wanted to get all of these, what I need to do is actually pretty simple, and we recommend doing this anyways. That is to take this, this query and use as table service query. Now the as table service query opens up a few options for you. If you take a look at this in here, you'll see that we have some methods in here like execute, Execute is actually going to, under the covers, take care of that continuation token, and it's going to just do it all for you under the covers. It's going to make multiple requests to the service every 1,000 or every continuation token it receives until the entire result set is expanded. Additionally, if that's not what you want, which it might not be if you have billions of rows, you can use something like the begin executed segment. And what will happen there is this is an async method that will allow you to call out, get the first set of results, and receive the continuation token. Then optionally, you can take that, resubmit it, and do it again until you're satisfied with the amount of data, or until you've completed your query or something like that. The other thing to point out here is this is where we have retry policies applied. So if you did nothing, absolutely nothing, did not use the as table service query, what would happen is we would submit the query to the service, and then if something failed, network cable got pulled, or in the middle of an update, we didn't get the download, or whatever it is, it'll just fail. You'll get a network error, system.net something. If we have the retry policy on here, we'll actually catch that, and depending on what policy you provide, which we have a few out of box, like exponential backoff and some things like that, it will actually retry that up to whatever the policy states.
Yeah, and one of the things actually that that people may just not think of when they think of retry policies is throttling. Like if you actually, now you have to be doing a lot of transactions, but if you really start to hammer a server in table storage, at some point you'll actually get an error back that says slow down. And the nice thing about the retry policy with backoff is that you don't actually really have to think too hard about what has to happen there, because your code will sort of automatically respond by using the default retry policy to those requests to sort of slow down and to throttle back. As I said, you have to be doing a lot. I actually haven't gotten throttled yet, no matter how hard I try. But if you're really doing a whole bunch of little tiny transactions, you can hit that, and you can get throttled, particularly while we're in the middle of moving a partition or something like that. So actually, as things get hot, that's actually a time where you really might see some errors that are really just, you should just retry, and everything's going to come back up in a short time. So it's a really good idea to make sure that you are using a retry policy.
That's a great tip. Now the as table service query is an extension method. It does return a cloud table query, which is a little bit different than the data service query. So if I were to run this, first of all, it would enumerate everything, which I don't want to do, because this infrastructure logs table happens to have hundreds of thousands of rows in it, and that would take a while. But additionally, this code down here as the data service query would actually fail at this point. So simple thing to do, a couple of tips in here on how to, first of all, handle paging, how to take a look at objects. You notice that I didn't have any class or schema defined ahead of time. I just kind of wrote it on the fly. And kind of figured out what was there just by looking at what the service returned to me. It was pretty simple to do. What you might get trapped on occasionally is if you try what I do and you get this error, you're missing some property. The reason is because by default the context has this property on here called ignore missing properties. When you get it like I did, it's going to be set to true for you. If you were to just create this on your own, I think the default might be false. And in that case, you actually will get this error. If you tried to run this query, you'd get this, hey, you didn't implement like the event tick count or something like that. So you'd have to go through and fill out the full CLR type for every single property that's in your table. But turn this on, easy. It'll ignore any missing properties.
Great.
And that brings us to, I believe, the tip of the week.
For the tip of the week.
What is it?
Well, you know what it means. I mean, if we're coming to the tip of the week, we've got to make a horrible request of our editor and ask him to put something in to introduce the tip of the week. And I don't know, this week I was thinking, I got my hair cut. It's kind of a big deal.
Yep.
So it was becoming a problem at work. It was blocking out the sun.
Yep.
We were getting kind of upset.
And it had its own funky smell.
It did. It was. I found. I found a sock in there that I just forgot it was up there.
You lost your code in there.
And so yeah. So I thought, in honor of my haircut, to introduce tip of the week, we should see what happened to all that hair that got shaved off.
It's a big ball in your drain.
And so we're gonna let our fabulous editor Bob interpret that however he wants. And so because without seeing that, it really wouldn't be the tip of the week.
It's gonna be an interesting one.
Are you ready, Ryan?
Yeah.
All right. Here is the tip of the week.
Oh,
I'm scared of this one.
Yeah,
I'm scared of everyone. Every week I'm scared at this point, but this one is particularly...
We can make faux mustaches with it. That would have been awesome.
That's an idea for next time around. So this tip of the week is very related to what we were just looking at here.
Right.
And it has to do with a place where you might get quite surprised when you do a query, and instead of getting no results, you get an exception.
Yeah. So I'm going to write a query here. I'm going to query against the partition key. So I'm going to look at something with the partition key and then the row key in this case. So I'm going to uniquely identify a particular row in here. I'll just delete this.
This, by the way, is like the best kind of query in terms of performance.
Yeah.
If you're specifying both a partition key and a row key, those are both indexed. Those go straight to the right server, straight to the right entity, and it comes back. So it's a good sort of query to do.
So I'm gonna actually put in some values that I know are good. I'm gonna just take these from some results we have here. Go ahead and grab this one, and I'm gonna stick these up into the query. So if we were to look at this, it's just a simple query where I create the foo and I say, give me the entity, take one, where partition key is a row key. I don't even need the take one in this case, because this at most will return one. Give me this. Now, the thing to notice when I first run this is this will work. Of course, I'll get back the result that I just saw. If I were to change this query, however, and intentionally introduce something I know is not there, and rerun this, it would still work. I will have this filter equal, which is great. So it's doing a query on this and actually returning no result. So I get a 0 for my I ordered queryable of foo. Why that is because we haven't hinted to the table service what is important about our class, or we haven't told it what is our identity information. If you use the built-in model that we have, you'll see that we've marked up all of these classes with system.data. Let's try that. Services common, data service key. So we have this data service key attribute, and we've marked them all up with something that looks like this. Go ahead, open up Reflector, find the table service entity. You will see this attributed onto it. What this does is it's a hint to the WCF data services client that and runtime that these are important. These are identity columns. This is a way we uniquely identify data within the service. So once we do this, and I actually hit F5, I'm going to get an error. Oops, looks like I spelled partition.
The partition key.
Partition.
I like partition key. That should be something.
I'm going to get an error. If I look at the query or the URI, you'll see that I've absolutely got a different query on there. You remember before I had this filter? Instead, this time I have this open parentheses, partition key equals and row key equals, and it doesn't have that filter syntax in here. So what we've done is we've said, hey, there's an identity here in the table. I want this particular entity. It's more of a get resource versus a query resource.
Right.
Well, when this happens, you could be, shaking your head. This causes errors in your application. Maybe someone's deleted an entity that previously was there. And what you really want to do is you want to say, hey, go ahead, get this entity, but if it's not there, don't throw this 404 exception error that I see. Instead, give me just a blank error. So you see right now we have a resource not found, 404. Mm-hmm. Instead, what I really want to do is get a null or a blank entity come back. The way you can actually deal with that pretty easily is to simply add another predicate that never fails. So in this case, it's and true. Right. Once I do that and rerun this query, you'll see that it changes back to the filter again. And then that way, the enumeration that comes back is actually now a query instead of an identity.
Right. So basically, those queries that just specify the identity, the keys, partition key and row key, are actually different on the wire. They look different. They and so they behave differently. And so when nothing is found, instead of an empty result set, that's a 404 because it's trying to get something specific.
Right.
And so the and true just sort of turns it back into, now it's actually a query, although it's a sort of silly query.
Yeah.
It's now a query, which gets you around that issue. And I did confirm with the storage team that doing that query is just as efficient as doing the query without the and true. So there's no loss of, you're not now all of a sudden scanning the whole table looking frantically for this thing. You're still going right to the right thing, and the results are the same. So sort of under that service head, we treat it all exactly the same way.
Yep.
But you get a different behavior. Instead of getting the 404 exception, you get an empty result set like any query that just doesn't have any results.
Now, if you're like me and you're playing with this a lot, you might discover one other thing, or you might say to yourself, I've never seen this happen. I do this all the time, and it never happens to me. What are you guys talking about? Well, it turns out that the ordering of this query is actually sensitive. So if I paste in the row key first, and not the partition key, and rerun this query, you'll see that it succeeds. It's treated like a filter, not like an identity.
So it's magic. The ordering is magic here. Which
ordering is magic.
I would claim is a bad thing.
Yeah, it's a little non-intuitive.
But it's a nice. It looks a little nicer than the and true, which looks really weird.
Yeah.
Although I suppose the and true is a little more explicit. It sort of calls out to the reader of the code that you're doing something.
Yeah.
I don't know which one is better. Ryan did find this by accident. I like it. That Ryan was trying to get the 404 error and just couldn't figure out why it wasn't happening. And it turned out switching the order actually makes a key difference there.
The last point on this is the behaviors changed slightly in the .NET 4 release of the client library. So there's actually a new property on there, I think, called ignore resource not found exception. If you set that, it doesn't matter what you do here. It's just it won't give you that 404 for identity related queries. It'll just return to you null.
So as soon as if you're using .NET 4, that's really the right way to do this. But you do need .NET 4 for that. Remember that in the cloud today, it is still .NET 3.5 SP1.
Correct.
And that version it's really in the system.data.services.client stuff. And those assemblies that are in the cloud are the 3.5 versions. They don't have that thing. So so for stuff that you're running in the cloud, for now, put and true or switch the order up. But as soon as you're onto .NET 4, there's that handy
you'll have a new
field for that.
Yeah, you'll have a new knob to play with. So with that, I would say, as always, feel free to contact us via Twitter. We're at Cloud Cover Show on the Twitter tubes, and we'll get back to you. We're very responsive. Our 10 followers have tweeted to us, I think, now 3 times at least.
Yeah,
and
we're keeping up.
We've always replied. So with that, the end of the show is here, and until next week, we will see you.
Thanks.